Greetings guys. So in this video we're going to have a brief introduction of the set theory, so get to understand the basics of sets. So my sincere apologies for the poor quality of the video and also the noise coming that you can get in the background. So yeah, we dive deep into the topic. So start with introducing the same definition of sets. Okay, let's start with the definitions. So we'll start by defining what sets are. So what are sets? What is a set? So a set can be defined as a collection of well-defined objects or elements. So the objects that are contained in a set, we call them elements or members. So you can see how we are progressing and how the mathematical language is changing from referring to the objects in a set as objects themselves, but we now call them elements or members. So there are a lot of things that are involved in a set, but we'll also proceed by defining other key words or aspects that we need to know. But before we proceed, let me just jot down the definition of sets so that you can also have it in your notebook. So we defined a set as a collection of well-defined objects or unique objects, or we can say a set is a collection of distinct well-defined objects. So yeah, so that's the definition we gave concerning sets. Now having this in mind, my assumption in this video is that you're the look of sets in your years at secondary school. But okay, regardless, we'll still get to know and understand whatever we have at hand. It doesn't matter, your background doesn't matter here. So we have what we call a universal set. So what is a universal set? A universal set can be defined as a set that contains all elements. So if you look at the elements that are given in a set, and that set which contains everything is what is referred to as a universal set. And the set that doesn't contain anything, well, basically we define that as a null set or an empty set. So this is a set that contains no elements, and we've got some symbols that denote an empty set or a null set. So the definition is written here. All right, so yeah, that's the definition of a universal set and a null set. Again, my sincere apologies for this poor quality of the video. So the denotion or a null set, and which is also referred to as an empty set, has got some symbols that denote them. So when you see this, it denotes an empty set. Sometimes we'll just write something like this to denote an empty set. So these things that we see, they are called braces, not brackets. So this, they denote these two denotions, they denote the empty or a null set. So getting back to the lesson that we're trying to put across here, like we earlier defined that a set will contain some well-defined objects. So you might be given a set containing the numbers 1 up to 4. So how do you denote that? So you show or write it using the braces. So this is the opening brace and this is the closing. So you write, you open here, so you're going to have 1, 2, 3 and 4. So this, they denote a set. So to show that an element is a member of a set, we use the symbol which looks like a E, this symbol here. So this symbol shows that an element is a member of a set. So for example, in this set that we have here, so let's call this set set A. And you should know that usually a set is represented by a capital letter. So you can have a set which contains numbers or letters, and those letters usually, or most of the times, they are going to be small letters. So that's what we use in set theory. So if you want to say 1 is a member of this set, set A, you can say 1 is a member of set A, or you can say 1 is a member of this set which is given, because we are given set A. So say 1, 2, 3, and 4. Right? Wonderful. So you can also do the same for 2, 3, and 4. So you can pause and attempt that and see how you can come up with a set that shows an element which shows that it's a member of a set. So to proceed with definitions, you might have a set which doesn't end, so to say, and which ends. So you're familiar with the terms finite and infinite. So what is a finite set? How can we define that? So keep in mind that a set is said to be finite if its elements can be listed down. So like for example, this set which we looked at earlier before is a finite set because we've listed all the elements in a set. So the opposite is true for an infinite set if okay, let's just have a set to give just a simple definition of an infinite set, since we understand what a finite set is. So a set is said to be infinity if its element cannot be listed down in a finite period of time, meaning it keeps going on, you know. So let me just give an example of a set which can be categorized as an infinity set. Let's say we have a set B, which can be given as 1, 2, 3, and the dots here. So these dots, they show that it keeps on going. Yeah, can be real numbers, positive integers, you know. That's an infinity set. So moving forward now, let's understand the most important part of sets. Okay, not necessarily the most important part, but this is very important in our understanding of the set theory. That's a set builder notation. Okay, so why are we looking at a set builder notation? So all right, so this video might cut any moment, so you look for a second video which I'll upload. So this will be a series of videos. So a set is often written in set builder notation, which uses variables. So why? Because sometimes a set can be listed down or it can be written. So if it's written, they use some variables such as x to describe elements of the set. So let's look at an example. For example, if we're given a set A, for example, let's say A is given by 3, 4, 5, and 6. So we're told to write this in, or to describe the elements of the set. So in short, we have to write this in a set builder notation. So we'll write so usually, like we said, the variable which is used to represent the set is x. So sorry, this is a brace here. So this will be written as A. We're now writing this in a set builder notation. So A, given this, so you open here, you say x. Want to know how it's read in set builder notation? So this is read as x, which are elements of x, such that sometimes they'll just write this. So you may write different two different things, but they mean the same thing. So elements of x such that x is a natural number between 2 and 7. Then you've written this in set beta notation. Okay, so this is key in the set theory because you might have a very long list of sets, so you just have to write it down. Okay, so we've got one more example here. So how can you write this in set beta notation? So you can see that these are vowels. Pardon me, we are supposed to have commas here. So we can write this as elements of x such that x is a vowel. So you've written this in set beta notation. How about this set? How can you write this? Very interesting. Dog, plate, and earth. We actually have dog, plate, earth, and food. Well, impossible. You can't write